Hey guys. All right, today you will be dividing complex numbers, so your title should be at the top of this next page. So the first thing we want to talk about is the complex conjugate. And complex conjugates of complex numbers, if our complex number is a plus bi, the complex conjugate is a minus bi. So what we're doing here is we're taking the opposite of our imaginary piece. So if we have the number 3 plus 2i, our complex conjugate would be 3 minus 2i. We take the opposite of our imaginary piece. So 4 minus 3i, the opposite of minus is plus, so this would be 4 plus 3i. On example 3, we have negative 5 minus 8i. The opposite of minus is plus, so this would be negative 5. Remember, we're only taking the opposite of the imaginary piece, plus 8i. So just remember, it's always just the opposite piece. All right, so we can easily identify our complex conjugates. So when we're, I just want to multiply our complex conjugates together really quick and see what happens. So when I multiply them, I have to distribute everything just like we learned yesterday. So a times a is a squared. A times negative bi would be negative abi. Remember, we're just multiplying. When things are next to each other, it's multiplication. Bi times a would be plus abi. Again, things are next to each other, we're just multiplying. So when I multiply, I can just put them all next to each other. And then bi times bi squared, bi times negative bi would be, positive times a negative is a negative. B times b is b squared. I times I is I squared. And then let's go ahead and combine our like terms. Well, I have minus abi plus abi. So if I'm subtracting and adding the same thing, these undo each other and they go away. And I'm left with a squared here. Remember yesterday we kept saying, well, I squared equals negative 1. So that means this would be minus b times negative 1. Oh, b squared, sorry. And negative times negative times a negative is a positive, so this is just a squared plus b squared. So when I multiply complex conjugates, what I'm going to end up with every single time is just a squared plus b squared. So this is a little formula that we're going to apply when we're dividing complex numbers. So when we're dividing complex numbers, we want to use the complex conjugate, this thing up here that we identified, to rationalize the denominator. So what that means, what that word rationalize means, is we just want to get the complex number out of our denominators. We don't like to have complex numbers in our denominators. So we're going to multiply by the complex conjugate to get rid of the complex numbers in our denominators. So the first step, I'm going to write some steps over here, and these are steps you can take notes also off to the sides, and these are steps you should follow for every problem. So step 1, identify the complex, I'm just going to write CC, complex conjugate of the denominator. Okay, so we need to remember the denominator is the bottom of our fraction. So here, the denominator is at 7 plus 4i. So the complex conjugate of 7 plus 4i would be 7 minus 4i. So here's step 1 right here. Okay, then step number 2 is going to be multiply the numerator, or that's the top of the fraction, right? And denominator, that's the bottom of the fraction, by the complex conjugate, so our CC. So I'm going to multiply on the top, 7 minus 4i, and the bottom, 7 minus 4i. So then I'm going to step 3, multiply on top. So on top, I'm going to do 5 plus 2i times 7 minus 4i. And this is just like what we were doing yesterday. We learned how to do this yesterday. So I have to distribute. 5 times 7 would be 35. 5 times negative 4i Well, 5 times 4 is 20, so this is negative 20i. 2 times 7 would be plus 14i. And 2i times negative 4 would be minus 8i squared. I combine my like terms, so 35 minus 6i. And then remember, I squared equals negative 1, so this would be plus 8, because we would do negative 8 times negative 1, and we would end up getting positive 8. So then I'm going to combine those two terms again, these two, 35 and 8. So that is 43 minus 6i. So on the top, I'm going to get 43 minus 6i. My step number 4, so this is step number 3 right here. This is step 2. Step number 4 is apply formula to the bottom. So what I mean by that is this formula up here that we just found. We're going to use that in step 4, okay? So because on the bottom, I'm multiplying my conjugates. I'm multiplying my complex number by its conjugate, 7 plus 4i times 7 minus 4i. So when I multiply those together, what I'm going to end up with is just a squared plus b squared. So if my complex numbers are written in the form a plus bi, and my complex number is 7 plus 4i, then my a value is 7, and my b value is 4. So in the denominator over here, I can say, well, this is going to be 7 squared plus 4 squared. And then step 5 is simplify. So here's step 4, and then we're going to do step 5. So simplify. What I mean by that is let's do 7 squared plus 4 squared. So this would be 43 minus 6i on top, and 7 squared is 49 plus 4 squared is 16, so I'm going to add those. So this would be 5, 4, 5, 6, 65. So I have 65 on the denominator, and that is my final answer. All right, I'm going to erase my adding really quick. All right, so let's do the same thing on number 2. Step number 1, identify my CC, my complex conjugate. So it's 2 minus I, that means my complex conjugate is 2 plus I. So I'm going to multiply, step 2 says multiply on top and on bottom by the complex conjugate. Step 3 says multiply on top. So 8 plus I times 2 plus I. 8 times 2 is 16. 8 times I is 8i. I times 2 is 2i. I times I is I squared. Combine my like terms. 16 plus 10i. Remember, if I'm going kind of fast, you guys can pause the video to catch up and ask questions of each other. Y'all work together on this. I squared is negative 1, so this is just minus 1. So then this becomes 15 plus 10i. So the numerator, the top of my fraction, let me zoom in here so we're not confused by the stuff on the previous problem. The top of my fraction is 15 plus 10i. The bottom of my fraction, I'm going to apply the formula. And so that says I'm going to do a squared plus b squared. Well, a here is 2, so 2 squared plus b. The b value is the number in front of I, and we understand there's a 1 here. So plus 1 squared. So 2 squared is 4, 1 squared is 1, so this is going to be 5. So we can simplify this a little bit. We can factor a 5 out of the numerator. So if I'm going to take a 5 out. If I take 5 out, then 15 divided by 5 is 3. 10 divided by 5 is 2, so that leaves me with 3 plus 2i, all divided by 5. Well, when I do 5 divided by 5, that's just 1. So here my answer would just be 3 plus 2i. Okay, so I want you guys to do the quick check. And there's one thing I wanted to address on here. So right here on number 3, my complex conjugate. Remember, this could be 3i, could be written as 0 plus 3i. So I just want to take the opposite of this. So the complex conjugate here would be negative 3i. So I would multiply on the top by negative 3i and the bottom by negative 3i. All right, I think you guys can do this. If you have any questions, please message me on Remind. I'll be at home. I don't mind messaging you guys back, okay? I will not be in class tomorrow because I have to give the English 2 STAR test. There's going to be an assignment posted on Canvas, so you guys look for that and work on that tomorrow. I think you should be able to do it from a phone if you don't have your Chromebook, but I do want you guys to have your Chromebooks with you so the sub doesn't have to worry about those, okay? All right, y'all have a great day, and I will see you around campus tomorrow and for sure in class on Friday.